14 2 on parallel and proportional parts. We're back to triangles, but we're going to do some splitting up of them. So this is what we should be looking at here. Okay. All right. This, remember, is one of the symbols saying these are parallel lines. So what that does is allow us some information. I have two triangles here, and I'm going to draw them out like this. So this one's G, J, and K. And we've got the bigger one. Now, admittedly, some of you are thinking, I can see the two triangles here. You don't need to draw it out. That's true, but some of us, it's easier for some people, and I'm one of them, it's easier for me to see them separated to do the comparisons of them too. Okay. The parallel line thing helps us, because right now we have to say, I mean, the question here is, how do you prove that this triangle and the bigger one, how do you prove they're similar? So I want to be able to say that this one's similar to that. Well, that means I need either AA or SSS or SAS. I need one of those three things to prove it. Already we know this one. This is the same one for each. And so, cool, we already know one angle. There's nothing about the sides. I have no information about the sides. So side, side, side is out. Side angle, side is also out because I don't have any information about the sides. Not enough to help me. Nothing at all. Parallel lines again. If these are parallel lines, and this line cuts it, and I'm told they're parallel because of that, I can use another one of those angle theorems from chapter 11. And in particular in this one, this angle and this angle, remember that if they're in the same place in the intersection, that's called corresponding. So I can say that this one and this one are corresponding angles. I could do it also for this one and this one. But if I do it just for this one, whoops, I've realized now that I need to put a double angle because GG is one single one. Okay, so that's a single angle. I chose that, so for this one, that. Which means over here, okay, so I have, right here now, angle G is congruent to angle G. I mean, that seems simplistic, but you still need to write it, you know, because they are two different triangles, even though it's the same angle form. And then I can say that angle I is congruent to angle H. Suppose I should make you write down by corresponding angles, but I'm not going to go make you do that. But now I do have one angle and another angle. So now I can say triangle G, J, K is congruent to triangle G, whoops, there's the triangle symbol, G, I, H by A, A.
You put angle I is congruent to angle H.
Did, and I did it on purpose and was just about to say, can anybody find my mistake? You just beat me to it. Good job. I purposely mixed those up. I guess I should have written something to prove that I purposely did it, because you just caught it before I even had a chance to say it. But yes, if I put G, J, K, I have to follow the same order here and do G, H, I. So this would have been wrong, so I got to fix it. In fact, I'll rewrite the whole thing. Good job catching that fast. So once you realize that the parallel lines help you out, that's pretty easy. So let's take a look at the next one down here. We're going to go a little step further. Okay? These are parallel. I could prove it, but I'm not going to ask you to prove it, because now you know that, oh, well, this angle matches both, that angle matches, therefore those two triangles are similar. So what I'm going to do is I'm going to give you a question. I'm going to put some information, 12, 8, x, and 3. And I'm going to ask this. What is the measure of GH? So we need to find out what x is. Because you see that this triangle and the bigger triangle, the smaller and the bigger, are similar triangles, because of this being parallel, you can go ahead now and match sides up. So if you think about what's happening here, we can see that this side 12 is in proportion to this whole side, which is 12 plus x. And this side 8 is in proportion to this whole side, which is 8 plus 3, which is 11. So if I were doing that up here on these others, this would be 12, and this would be 12 plus x. This would be 8, and this would be 11, because I'm adding those two together. So because these triangles are congruent, let's go ahead and now put these in proportion to solve it. I can say that the 12 is in proportion to the 12 plus x. And also the 8 is in proportion to 11. That's how you'll solve for x. You will use the proportion thing. One side matches the other side, one side matches the other side, and since the proportions are going to be equal, like 1 over 3 equals 1 over 3, because they're congruent triangles, you can do that. So now what you're going to do is solve it. So let's cross multiply. 8 times 12 plus x equals 12 times 11. 8 times 12 is 80, and 12, that's 96, plus 8x equals 132. Quick little pause for something. Yes, question?
Would you not reduce the 12 at all?
You can't reduce here because of the fact that this is grouped together. Because when you have a division symbol, that's a grouping symbol. So these have to stay together. So you can't like do a separate one like that. If this had been on top, then you could have had 12 over 12 and x over 12, and that would be different. And when it's on the bottom, now you're stuck with it as a group thing. So a little aside now. One of my favorite little tricks in math is multiplying with 11. Okay? So if I did 11 times 36, that number is 396. 11 times 14 is 154. 11 times 71 is 781. Got a little trick I'm doing with it. Does anyone know that trick, what you do with 11s? Do you know that, AJ?
Do you multiply it by 10 and then add the number?
Hadn't thought about that, that would work. I'll have to try that. There's a different one, so that's an idea. I'm not sure that will. Let's see, multiplied by 10 is 360, and then add 11, or multiply. No, I'm not sure that works for each one of them. No problem, good idea.
Oh, wait, I see what you're saying. Like, multiply 36 by 10 is 360, plus 36, 396.
Multiply 360, and then 36. 360, that may work. That would give you 396.
Oh, yeah.
So that does work. That's a new one. Both of you, good job. What I'm thinking of is, if I do 11 times, let's say, 53. Take the 53 and add it together. You get 8, right? Put that right in between these. 583. 11 times 53 is 583. All you have to do is add them together. So you could do what you said, multiply by 10 and then add the number in, and I think that'll work. I'll have to do that on 5 or 8 of these to check and see if it works all the time. But the one I like, I can do even more easily in my head, is just add the two numbers and put it together, and put it in the middle. So 11 times 17 is 187. 11 times 51 is 561. 5 and 1 is 6, and put that in the middle. If you get a one where you have to carry a number, you can do that. If I do 11 times, let's say 47. 4 plus 7 is 13. So I'll put the 3 in the middle, but that 13, that 1 I'll add to the 4, so it'll be 537. So it's a nice little trick. When I get to an 11 like this, I like to toss something like that out because I find that interesting. Okay, so that was just a little aside. That's how I come up with 132 so easily. I know my numbers pretty well, but I like to do that. Yes, AJ?
I don't think 11 times 47 is 537 because you multiply it by 10, it's 407, and you add 37 to 517.
I copied, so I could be wrong. Let's see, 4 and 7 is, oh, it's not 13, it's 11. Okay, if anybody, no one else caught me on that. Thank you, you're right. That's because 4 plus 7 is 11, not 13. I don't know why I was thinking 13. So that should be 570. Okay, so you're right. Okay, now let's come back to here. So I have 96 plus 8x equals 11 times 12. Let's continue to solve it. Subtract 96, and I have that written down somewhere, but I forgot what it was. It's 36. And when you divide by 8, you get 4.5. Okay? Now, I got that x equals 4.5. The thing is, that's not the answer. I solved for x. But the question was not, what is x? The question is, what's the measure of GH? So GH over here is 12 plus x. So I have to put the 4.5 in here. I have to say that 12 plus 4.5 equals 16.5. It doesn't say here if it's centimeters or inches or whatever, so I'll have to use units. Okay. So, let's review this part. Because these are parallel, you can see that these two triangles, the smaller one and the larger one, are similar. That allows you to put the sides, to put the sides in proportion, 12 over 12 plus x, and 8 over 11, and then you just solve for x. But remember to put the x back in to get what it is that you're being asked for. Okay, let's look at the second page here for 4.2, or 14.2 rather. And now we're looking at the mid-segments. So there's a couple of little things about it if it's a mid-segment. If I don't have those little lines here, then I don't know that this is right in the middle. By having these lines telling me that this distance is the same as this distance, that means that point is exactly in the middle. Okay? And because these are parallel, and these two go together, then that means also that it's in the middle. If I don't have them as parallel, I could still know it's a mid-segment if I knew that these two were also equal measure. Then, this point would be in the middle, that point would be in the middle, and I could draw a line through it. If I don't have this, I have to have the parallel. Okay? If I don't have either of those, that's not enough to say that it's a mid-segment. So I'll have to make sure I give you enough information, and you have to watch for it. Or I could give you one that's tricky and not give you enough, and you have to say, it's not really a mid-segment, so I can't do the problem. So, what we're going to do here is figure out some information about it. The fact that these are parallel, and the fact that these are the same, means that this is right in the middle. Right? And whether this, like on the last one, last couple, this line was down further, but because they were both parallel, and you could have corresponding angles, you could say that these two triangles were congruent. You could do the same thing here. This one is congruent to this one, okay? But now let's take a look at the measures, and what we're going to do is find out certain information. I'm going to tell you that this amount is 12. If that's 12, this has to be 12. L through J is the amount of, I'm going to say 20, but okay. This is not going to be in proportion. I just realized if that's 12, this shouldn't be 20. Because that should be smaller. So what? The idea here is not that that matches, although I think I'll change this next time I do this.
If it's 12 or 20, that's still 3/5, so it does line up.
Yeah, it should work. However, I'm going to do this up here. I'm not going to give a number there. I'm going to give 3x plus 2. So the question is going to be, among other things, solve it. So what I want to do here is to find what is the measure of line AL. Now, this becomes pretty easy. You don't even need the other information. If you know, if there's enough information to say, and actually these lines are enough here, then you can say that these two are equal and just solve for x. Yes?
If that line in the middle is in fact a mid-segment, that would make AL 20 because both sides of a mid-segment are congruent.
You're absolutely right, and this also helps, but we need to find what x is. Oh, so actually what I should do is not say that. In this case, I should be saying solve for x, because it's too easy to say that's 20. So one more step is let's solve for x. So if that's going to be equal to 20, let's do 3x plus 2 equals 20. Subtract 2. So x equals 6. 6 times 3 is 18, plus 2, that does indeed prove it's 20. So that's one way you'll use that, use the fact that they're equal and just solve for x if needed, or recognize it so you can say that it's 20. The other thing that you need to know if it's a mid-segment is if I tell you that this amount here is, say, 9, if that's the amount of 9, a mid-segment is half of the bottom line. So that means that kj is double that. If that's 9, that leads to this one being 18 units. Or if I told you that this one was 18, you would say that m through L is 9. So you want to recognize that the mid-segment is half the base segment. Or you can say the base segment is double the mid-segment. Either way, they would both be true. So based on what you're given. So I'll go like this. So this is 2 times, this one is 1/2. 2 times 9 or 1/2 18. Okay, let's look at the bottom one, multiple parallel lines. See how far we get today. Notice the information that I've given you here. We have 3 lines that this is telling you that they're all parallel, and they're all parallel to each other. And then these 2 things tell you that this length is the same as that length. So in this kind of case, that information is enough for you to solve if I give you something to solve. So what I'm going to do is I'm going to say 3x minus 7 and x plus 5. And over here, I'm going to say that this length is 9y minus 2. And this length is 6y plus 4. So we'll solve for x and we'll solve for y. Okay? And then, yeah, then we'll do that, and then I'll add one little part to it. Not too much with it. So all I really have to do, because of these, I can say this is equal to that. 3x minus 7 is equal to x plus 5. So let's solve that. Add 7, 3x equals x plus 12. Subtract x, 2x equals 12, x equals 6. Now, if I ask you solve for x, you're done. If instead I asked you and say I numbered these, lettered these, and say that's A and that's B, call that C, I'll call this one D, E, and F, just for the fun of it. If I asked you what's the actual length of A to B, then you'd have to put the 6 in here and do 18. So if I said AB, the amount of AB is 18 minus 7, so it would be 11 units. So I don't know which way I'll ask you, just be ready. If I just say solve for x, you have to do that. If I say solve, give me the amount of the length, then you have to put the x back in for it. Okay. Now, these 2, let's do this one. 9y minus 2 and 6y plus 4. Now the interesting thing is, if I didn't have these as parallel, we wouldn't know that these 2 are equal to each other. These tell us that AB and BC are equal measures. But we don't know that about these unless these lines are parallel. So this information is vital. If these are parallel, then, and these lengths are equal, then the lengths over here have to be equal too, and that allows us to put these equal to each other. So actually what I should do is equals 6y plus 4. I'll add the 2 to both sides. 9y equals 6y plus 6. So add 2, subtract 6y, and I get 3y equals 6. Divide by 3, and I get y equals 2. So y equals 2. If I put that back in here, let's see what the measures are. That's 18 minus 2. That gives me 16. 2 times 6 is 12. 12 plus 4 also gives me 16. Okay, now I know that those amounts are 16. Okay. Any questions about that? The main thing is there has to be enough information. If I just told you these are equal, and then that wouldn't be enough for these to be equal. If I just had that these are parallel, that would not mean that these are equal, because saying they're parallel, this could have been down a little bit further, and then this side's larger than that one. But you don't know that, that's why these lines are vital to tell you that. Okay, that is end of 14.2. So from this, make sure that you recognize the proportions, recognize to make equal, or recognize to make proportions and solve for x, and then figure out if you need x or if you need the measure of one of the sides based on that, or one of the lengths.